Hello everyone, my name is Himanshu Sharma and in this video we will work on thread and related concepts in Java. So let's get started, and first let's see how we can create threads. So if you're working on Java 8 or above version, you can use the Lambda approach, and for that what you have to do is we'll create a variable and then we will use the Lambda expression to define the run method, and here we will say printing from lambda thread, and let's get the name of the thread. In fact, let's use the method to set a custom name and we name it as lambda thread. Alright, so this is the lambda approach, and let's run our thread, and for that we will invoke the start method, and then let's print one more statement printing from main method, printing from main thread actually, because whenever your Java application is running, your main method is already using one thread. So printing from main thread, and here we will again say current thread dot get name, and that's it. Yep. Okay. Yep. Now let's run it, and we should get two results. And yes, we got the message from both the threads. Now another approach is we will create a class which will implement runnable interface. And since we are implementing an interface, we need to override its run method. And we do the exact same thing over here. And instead of lambda, let's name it as runnable thread, printing from runnable thread. And to run this thread, what we have to do is we to call thread runnable thread new thread, and then here we will pass the runnable thread object. So it will be like this, and if you go to this constructor definition, we'll see it is actually looking for a runnable type, so that's why we implement a runnable. So now we say runnable thread dot start. All right, so let's start it after our lambda. Let's run this, and we should expect 3. Yeah. Now the third approach is we will extend the thread class. So we say extends thread, and we again do the exact same thing with one minor difference. Here, since we are already extending the thread class, we don't need the static reference. We can directly call this object. So can say over here this, and we can say class thread printing from class thread. And again, since we are extending the thread class itself, we simply say class thread equal to new class thread, and we say class thread dot start. That's it. Let's run the application, and there we go. We got all our messages from different threads, and I hope you get the idea of creating the threads in 3 different ways and the difference between them. The first one is the short and concise approach, where you are not expecting to create a dedicated class for your logic. The second, runnable, is the most recommended one because it also gives you the freedom to extend your class with any other class if required in future. And the third one, here you are not implementing the runnable, so you are losing the that flexibility of extending any other class. But what you are gaining is you are gaining all the methods which are already defined in the thread class. Like over here, we directly use this object. So there are many more methods which, if you are interested, you can use them. But usually the runnable is the most recommended approach. So yeah, so these are the ways how to create a thread. Now let's move on to the thread coordination part. So let me open a different Java file. I have this already created. So here what we are doing is we are creating a custom thread. So basically we are using the Lambda approach over here, and yeah, we are just creating a custom thread, and what it will do is we're setting the name and we are putting uh, the thread to sleep for 5 seconds, and after that it will print the message, and that's it. And then you can see over here we are using this try catch block. We are performing an interrupted exception handling, and that all because of the sleep method. So we are using the sleep. Let's run it and see how it behave. Okay, I think we missed something. Oh, we haven't started it yet. So basically this is the custom thread. So let's start this thread, and we say custom thread dot start, and then let's run it. And you can see over here it's waiting, and now it print the message, and we exit the application. So let's say I don't want to wait for 5 seconds. Let's say once your custom thread got started, you want that, okay, I'm doing something, and what I will do is I will put a sleep in our main thread. So let's put the exception over here, and then I don't want to wait more than 2 or 3 seconds to finish this thread. So what I will do is I will say custom thread dot interrupt. Now what will happen is whenever you invoke the interrupt method of a thread, internally it will trigger the interrupted exception. So when you are interrupting the logic, basically the one which is handled in this try block. So when this method is invoked and the processing is somewhere around here, you will get the interrupted exception, and this message will get logged. So let's run this application and see how it will behave. So you can see just after 2 seconds, we interrupted the thread, and that means it was over here. It was waiting for 5 seconds, and it might be somewhere around 3 seconds when we interrupted it. And as soon as it got interrupted, the interrupted exception block got triggered, and we get the message printed if thread interrupted. We did not get the printing message. So that's how the interrupt method will work. So basically interrupt method will trigger the interrupted exception, and then inside your thread block you need to handle the interrupted exception accordingly. Now let's say I add a message over here and I say printing from main thread. Okay, and let's say we are not focusing on the interrupt one, and we are also not focusing on the sleep. That's it. That's the implementation we have. So what will happen? it will trigger the custom thread, wait for 5 seconds, and it should print the main method. So let's run it. Yeah. Did you observe this? We already got the printing from main thread, right? And after 5 seconds, we are getting the custom thread message. So what if I want the application, if I want to enforce that I will only get this message once the custom thread is finished, no matter how much time it will take, but I want this message to be printed only after the custom thread message is printed. So what we can do is we will use the join method. So I will just put join over here and I will run the application. And now you can see we are not getting the main message because our application is first waiting to complete this part, the custom thread, and then put a main thread over here. All right. And then there is one more thing. You might have heard of daemon threads and how that will behave. So let's remove this join part. Okay. And now if I run my application again, just focus on when the application is getting exit. It's still running, see, right? I don't want to wait the whole application just for a single thread. So what I will do is I will mark this thread as daemon. I say like, okay, I have triggered this thread, but I don't want to wait for its completion, and I can go ahead and exit the JVM. So let's say I set the daemon as true, and that's it. So before starting, I'm marking the thread as a daemon thread. Now if I run it, you see our process finished instantaneously. It did not wait 5 seconds to get this message. So daemon threads are usually used in background activities where you just trigger something and you just forget it. So that's where the daemons come into picture. And yeah, that's it in this part. We go through the join, we work on the interrupt, and we get to know about the daemon. So this is in the thread coordination part. So now let's move on to the race conditions or synchronization you might have heard. So let me close this, and I have a race condition Java file. So let me show you what's happening over here. First of all, we have a shared class. Okay, and in this we have one variable and then two methods. One method is adding 1 and another is just subtracting 1, -1. And the third method is returning the result. That's it. A very straightforward simple class and a very simple operation. X plus plus, x minus minus, that's it. And now we created a object of that class and we provide that same object to two different threads. Now what these threads are doing is the first thread is our add thread, and I hope now you're getting the idea of the how the threads are implemented. These are again the lambda implementation. So the add thread is running for 10,000 count, and it will keep on adding 1. Okay, and then the minus thread also run for the 10,000 count, and it will call the -1 method. We started both the threads and we put the join so that we can wait for the final result. So let's run this application and see what will happen. So basically we are adding 10,000 and subtracting 10,000. So whatever our initial value, we should get that, right? Every time in the final result. So let's run this application. Let's run it. We get a different result. Might be intermittent. Let's run it again. Oh, we again get a different result. So no matter how many times you run, every time you will get a different result. Why it's happening? Because these operations, these simple operations, are not so simple. Basically, even the x plus plus is a combination of multiple CPU instructions where you are adding one in a variable and then assigning. They are like kind of two or more operations happening. So like similarly for x minus 1. So now what happens is when your two threads are running, there might be an occurrence that during the add thread, the x plus 1 did happen, but that final value is not yet assigned to the x. And in the meantime, minus thread got the time, uh, and the minus threads x minus 1 got triggered on an older value. So how can we solve these issues? How can we mitigate these solutions? Mitigate these problems. So what we can do is we will just keep it like that only. And the only thing we have to do is we will just use the synchronized keyword. We will say we are going to synchronize both the methods. And what this means is, since we are synchronizing the method at any given point of time, if multiple threads are trying to access these methods, only one of the thread can access one of this method. So now if I run this, and this time no matter how many times we run, we always get the consistent result and the correct one. So this is about the synchronized keyword. Let's say you want to use the synchronized at a section level. So when we are saying section level, the approach is basically like this. So we say, let's we can say it like this. Okay, and again we can say it like this. So what we are doing is we are specifying this object on synchronized, and now let's run it again, and we again get the correct result. So this can be used like in case if you want to use multiple objects, like you want to use two different objects. So you can say new object like this, and we can create one more. So basically what we are doing over here is whenever a thread come and look for this section, it will take the lock of object 1, right? So now in that case, any other thread who try to access add 1 again, it won't be able to do that. I mean, it won't be able to perform the synchronized section part because object 1 is already locked by another thread. Although in this case, if another thread comes and try to use the -1 section over here, it can still able to do so because we are putting the lock on a different object. So in that means object 1 and object 2 approach, if we try to run it again, we again end up in our problem scenario. So let's run it, and you can see over here, because we are giving independent threads, so again we are ending up in the scenario where two threads are operating on our data independently without considering what other thread have already done or is doing. So this is the part for the race condition and synchronization. So let me move it back, and you can write it like this, or let's keep it on the method only. All right, so now you get to know about the race conditions and the synchronization part. Let's move on to a class about reentrant lock. You might have heard that reentrant lock class. So what it do is it actually provides you a few more utility methods which you can use while taking up the lock on an object. So let's go through this example over here, and so here what we did was we created a class, shared reentrant class, and again we have a data variable. Along with this, we created a lock variable, which is a reentrant lock object, and then we have a getter setter for our data and just a getter for our reentrant lock object. Now if I go to the main method over here, we will create a single object of our shared class, and then we have two threads, a read thread and an update thread. So now what is happening is the read thread and update thread both will run indefinitely. You can see over here they both are starting with while true, right? It's an indefinite loop for both of them. The read thread will sleep for 50 milliseconds and take the lock and then print this message, the current time and the current data value. Okay, and finally it will unlock. So after every 50 millisecond it will acquire the lock. Before this the lock is not yet acquired. It will only acquired at this line number 14. Now in the update thread what it will do is it will sleep for 100 milliseconds. Okay, and after 100 milliseconds it will first check. So here you can see this try lock. We have not referred this try lock method earlier. So this try lock is actually part of reentrant lock class. So you get this try lock method and you can use it to check if a lock is available or not. If it is available, it will be, you will automatically get it. You don't need to ask for lock. So if it is true, you get the lock and then you just need to unlock it. If it is false, we will print that lock is not available. Right? So in this way, what will happen is, like, if two threads are running, and in both the case, if we say to acquire the lock, then two threads are actually, the CPU time is getting lost in providing the resources between the two threads because they are fighting. While in the try lock approach, the another thread is not fighting. It is just asking, like, if the lock is available, I can take it. Otherwise, I will just log the message that not available, and you can continue. So now let's run this application, we just start the threads, we put the join, and that's it. Though this will never get printed because it's an indefinite thread for both of them, indefinite loop for both of them. So let's run the application. We need to observe the statements, the print statements, and let's stop it for now. You can see we are getting these messages, right? And then you can see over here at 21, 22, 23 the number. This is their data which is getting changed, and that change can only happen through this statement, the update thread. Okay, so what is happening is whenever the update thread is getting the chance, it is updating. Okay, but when it is not getting the chance, it will just throw the lock, it will just log the lock not available. And we can see over here, we are getting couple of lock not available statements, right? So this is how you can use the reentrant lock class. Now there is one more variation of a reentrant lock class, and that is reentrant read write lock. So let's move on to that, and this is the example for our reentrant read write lock class. So again, we created a class with a data, and here we created a lock object which is reentrant read write lock. And from reentrant read write lock, basically you get two lock objects. One is read lock and the another one is write lock. So there are couple of rules. First one is read lock can be acquired by multiple threads. Okay. Second, read lock cannot be acquired if write lock is already acquired. And third thing, write lock can be acquired if read lock is not acquired. And the fourth, write lock can be acquired by only one thread. Okay, so here we have two threads, read thread and update thread. The read thread one, they both are again indefinite loops, but the read thread is using the read lock. So you can see over here from that shared object, we use the read write lock, and then we are using the read lock. While in case of update thread, we are using the write lock. Okay, so what we are going to do is we will run the read thread indefinitely. We try to get the read lock first. If we did not get it, we will say did not get the lock since write in progress. If we get it, we simply say we print the thread name and the current data, and then we unlock it. So again, if we get this statement as true, we don't need to lock it, we just need to unlock it. You already get the lock. Same over here, but in this case we are sleeping the update thread for 100 milliseconds. So if we get the lock, the thread will sleep for 100 milliseconds, take the lock for 100 milliseconds, then update the data and then unlock it. If it did not get the write lock, it will print did not get lock since read in progress. Okay. So now let's run this application. And let's stop it because it's indefinite. So it will lock too much in a single go. So here you can see we are getting the statement did not get locked since read in progress. So okay, so that means these statements are coming from write method, right? Right, update thread. Here you can see the thread is getting printed, which is happening from the read threads over here. Read thread run method. So this is where it is happening, and then again we are getting the lock. So you can see the method it's not getting the lock, that's why the counter is still 13. And let's move up, let's see we get the other one. Let's move up. This is read. Let's see if we have any right one. We should have, because the counter is already incremented to 13. So okay, I think we lost the buffer. So let's run it again quickly and we will stop it. So let's run it again and let's stop it. See, here these are the logs we are getting. Did not get the log since write in progress. So this is coming from the read thread, right? This is coming from the read thread. So that's how it is. Let's clear out. So this is how the read write, reentrant read write log class is used. So the use case is like when you have a scenario where you expect multiple parties to read, and a very or you can say only a unique party can write at that point of time. So in this case we are using the read log and the write log objects. Now let's move on, and another one we have is semaphore. So in semaphore is actually you can consider semaphore is like it works on the concept of permit. So you can only allow that much of people uh, uh, that you can only allow a certain number of people, and that number only depends upon the how much permit you have. Let's say in a parking lot, if you have a parking space of 5 cars, you can only allow 5 cars. The sixth car can only be included in the parking lot once one of the existing 5 cars got removed, right? So it works on the concept of permit. So let me show you here. Here what we do is we create a simple class, and this is a semaphore shared class. So we are naming it as shared class. Every class you see in other examples also, because we are using this class as the shared object or a shared resource among different threads. And inside the shared class, we are using a semaphore, and we allowed the permits as 2. So even if you just go to the semaphore, you can see over here their definition, it's more towards the permits, like how many permits you can say, or how many tickets are allowed, or how many passes are allowed. So that way. Yeah. So here, reentrant read write log. Oh, sorry, my bad. We end up on a different class. Yeah, again. Sorry for that. So shared class over here, we have a semaphore with permit 2, and then we have a getter for this semaphore, and then we have two methods, producer and consumer. Producer will log a message produce data, and the consumer will log a message consume data along with the consumer number. Okay, so let's move on to the main class. Here we created a producer thread, and it will run indefinitely, and it will log the available permits. So it will say shared get semaphore available permit. So this method is available as part of your semaphore class. You can just go over here. So it's an existing one. Okay, and then what it will do is uh, it will acquire a permit. Okay, so here here the thing is not about locking and unlocking, it's more about acquiring and releasing. So those are the terms different over here. So it will acquire. So as soon as it acquire, one permit got reduced. So let's say you have two permits. As soon as a thread invoke the get acquire, or sorry, the acquire method, it will become one. And then it will sleep for 1 second. And then it call the producer method, which will just display produce data. And finally, it will release the semaphore. So as soon as it release it, it will putting that permit back to the available permits list. So this is what producer is doing. Then we have three consumers which are doing the exact same stuff. So I will pick one of them. So the consumer will also run indefinitely, and they also do the same thing. They will acquire the semaphore, but they will sleep only for 500 milliseconds. And then they will invoke the consumer based on their consumer number. So it will print consume data and 1. And then they will eventually release. So that's how the three consumers we have defined. So we have started our producer, we have started all our consumers, and we put a join of all of them. So let's run this application. And you can see over here the available permits 2, available permits 1, available permits 1. You can see the permits count is getting revised, right? So now and into the consumer logs. Yeah. So what we are saying is that this permit number, this is getting revised. So now it got 1 again, based upon how many permits are already consumed. So even though we are running the three consumers, even though three consumers are running, they will only share 2 of the permits, right? So this is the semaphore. Okay, so after this, let's move on to our, I would say, second last part, and that's thread coordination. Sorry, thread communication. So in thread communication, what is happening is we will work on the wait, notify, and notify all methods. So these are the methods which threads use to communicate with each other, right? So when a thread says notify, it is actually telling other threads that, okay, you are free to contest for the lock. So for thread communication, we have a shared class which contains two methods, method A and method B. They both are synchronized method, and what method A is doing is it's taking a number and it's printing out that number, and as soon as it prints out, it invokes the wait method. So as soon as it invokes the wait, it will not log the any further statement. The thread goes into the wait state. And then in the method B, we are just simply printing a message that processing done, and then we are invoking the notify all method. So that's all in this shared class. So now how it's being used, let's see over here. We created a common object of that class. Okay, and in thread 1 we are calling the method A, and then we have another thread 3, and here again we are calling a method A with a different number 3. So basically two threads are calling the same method A, and one thread is calling the method B. And how it is calling is, it will go to sleep for 5 seconds, and after that it will call the method B, and what method B will do is notify all. So just to summarize, two threads will call the method A, and as soon as they call, they will get into the wait state. Okay, after that 5 seconds later, another thread will call method B and it will invoke the notify all method, notifying both the threads that you are free to take the lock. So let's run this application now. You can see over here method A started 1 and method A started 3 by thread 1 and thread 3. And finally we have our processing done after 5 seconds, and then we got the messages from both the threads, notification received and finished. So now you get the idea of wait and notify all. So let's do one thing, remove the all part. Let's call the notify. Okay, and now let's run it. So again we have 1 and 3, invoke the method A. Processing done, notification received. So notification received means one of the thread logged the notification received, right? And the processing done is already happened by our other thread, the one which is calling the notify method. But here's the catch. Now the application is not yet stopped, right? Because one of our thread is still running and we put a join over here, right? That thread is in waiting state. It's still waiting to get a notification. And this is the difference between notify and notify all. So what happened is, if I call the notify all threads got notified that they can contest for the object, right? They can come out of their wait state. But notify will only tell one of the thread to get to come out of the wait state, means all the other threads will remain in the wait state. So to solve that, instead of calling notify, we will call the notify all. So let's stop it, run it again, and method A started 1 and 3. So thread 1, thread 3 both running, both got the notification, and that's why they both logged their respective messages and finished. In case of only notify, only one of the thread get the notification and the another will remain in the wait state. All right, so this is all. And yeah, one last thing, you might have heard about deadlock, right? It can be viewed as a, you can say, a traffic jam in our system. So what happens is, in case of deadlock, what is happening, two threads have their resources, have certain resources with them, and now one thread need a resource which other thread have, and other thread needs a resource which the previous thread have, and that's why they keep on fighting and get logged, because nobody trusts each other, and thread 1 cannot provide the lock it already have, and the same goes for thread 2, and they both end up in a locked state because they are dependent on each other. So how this scenario comes up? So let's take an example of this shared deadlock class. So you remember we went through creating the synchronized section using two different objects earlier. So we use the same approach over here. In method A to B, we have a synchronized section which is taking the lock on object A, and we are printing that we have a lock on A and we are going to acquire lock on object B. And inside that section, we have another synchronized section which is going to take the lock on object B. And inside this, we are printing having lock on object B. Now, in case of B to A, we just reverse the order. Here, we have the section of object B first, and we are saying having lock on object B going to acquire lock on object A, and the inner section having lock on object A. Now, we created two threads which will run indefinitely. One thread is calling method A to B, another one is calling B to A. Right? So let's run this application and see how it will behave. You see over here, your application is not yet ended. And we just getting two messages, having lock on object A going to acquire lock on object B, having lock on object B going to acquire lock on object A. So this is the deadlock. This is our thread 1, which is over, which call the A to B and printing this message. And this is our thread 2, which is this thing, calling method B to A and printing this message. None of them reaches the second section because of the interdependencies of their lock objects. So how to solve it? So you don't have any like utility method or anything to help in such scenario. It should be handled more in a programmatic way where you need to decide how the ordering. So in this case, we need to make sure that if a certain order is already followed, we need to make sure that same order should be in place for others in methods to avoid such issues. So here what I will do is I will just change the ordering. I'll say object A to be in the method B to A method, right? So now if I run it, I will not get that locking, and see both threads are working fine. So that's all in this video. Thanks for watching. If you have any suggestions or feedback, please let me know in the comment section. I hope you enjoy it. Thank you everyone and have a nice day.